Okay, now we are going to consider another one, arithmetic mean. Now, if x, y, and z are consecutive terms of an arithmetic progression, then the middle number, that is y, is the arithmetic mean of x and z. Now let's check what we are looking about here. Now, if we have x, y, z as consecutive terms of an arithmetic progression, then from our knowledge of common difference, we say common difference is the second term minus the first term, or third term minus the second term, or fourth term minus the third term if you have other terms. So the common difference, that is the common difference here, is what we use to get the arithmetic mean. So which is second term minus first term, and the same thing as third term minus second term, and that's what we have here. Alright, since these two will give us the same result, then by implication, y minus x is equals to z minus y. So if we simplify this by collecting like terms, we have y here, bringing this one back, we have plus y, equals to taking this minus x to this side, it will give us positive x, then plus z. So y plus y is 2y, equals to x plus z. So y now is going to be x plus z all over 2, that's if we divide both sides by 2. So this one, x plus z all over 2, is called arithmetic mean of any AP given to us. And don't forget, you have three consecutive terms, the middle term becomes the word arithmetic mean. For instance, if I have 2, 4, 6, these are consecutive terms of an AP, isn't it? So the middle number, which is 4 here, is the arithmetic mean of 2 and 6. And using the formula here, we'll just say 2 plus 6 all over 2, and that is 8 over 2, and we'll have 4, just as we have explained here. Alright, let's go to the example we have here. The first question here is, find the arithmetic mean of A minus 14 and 16, B, x plus y and 3x minus 4y. So let's take our solution. The first question, the numbers are minus 14 and 16. So the arithmetic mean is going to be, just take the average of minus 14 and 16 by the formula we have here. So it's just like saying we have minus 14 and then we have y, then we have 16. So we have to find y now. So that we now have our y to be minus 14 plus 16 all over 2. And minus 14 plus 16, which is the same thing as 16 minus 14, will give us 2. So 16 minus 14 is 2, so we have 2 all over 2, and we have 1. So the arithmetic mean of minus 14 and 16 is what? 1. Okay? Good. Now, the B part of the question now, the terms are x plus y and 3x minus 4y. We have them here. X plus y and 3x minus 4y. So their arithmetic mean is going to be x plus y plus 3x minus 4y all over 2. That is, we pick our x plus y plus our 3x minus 4y, because this one means the same number and this is also a single number too. Okay, so in this one we have like terms, that is x and 3x are like terms, so we can now add the like terms here. X plus 3x will give us 4x. Then we have y and minus 4y, they are also like terms, so we have y minus 4y, we get minus 3y, so we have minus 3y all over 2. And if you want to simplify this one further, you have 4x all over 2 minus 3y all over 2. And 4x over 2 will give us 2x. So we have minus 3y all over 2. And that's the arithmetic mean of x plus y and 3x minus 4y. Let's take another example and then you see how it goes. The second question here is, if minus 10, p, q, and 20 are in AP, find p and q. So that's if these are consecutive terms of an AP, then what will be the values of p and q? Now to do this, if we check, we have 1, 2, 3, 4 terms. Okay? Now, how will we get the value of P and Q? We can get the value of P and Q if we know the common difference here. And in this case now, since we have 4 terms, and then that means this 20 is the last term. And don't forget, we say L is the same thing as A plus N minus 1D. That's our last term, which is the same thing as the N term. Okay? So we have A, the first term, which is minus 10. Then N, we have 1, 2, 3, 4 terms. So N is 4, and then D is what we are now looking for. Our L is the last one, which is 20. So we just say 20 is equals to minus 10 plus N minus 1 D. And then we say N is what? 4. So instead of this N now, we have 4 since we have 1, 2, 3, 4 terms. So that we have 20 is equals to minus 10 plus 3D. 4 minus 1 is 3, then times D, we have 3D. Then we collect like terms, 20 plus 10, that's if you take this one back here, it will give us positive. It's equals to what now? 3D. So 20 plus 10 is 30, equals to what? 3D. Dividing both sides by 3, we'll have D to be 10. That's the common difference. Now, if the common difference is 10, then P will be minus 10 plus D, which is minus 10 plus 10, and we have 0. And then Q will be P plus D, and P is 0, and D is 10. So we have 10. Therefore, the AP is minus 10, P 0, Q 10, and then 20. And the values of P and Q are 0 and 10 respectively. So that is how we can handle questions of this type. Okay, that is that for arithmetic mean. Let's take the last thing on AP, which is sum of terms of an AP. Now, from our introduction, we talked about series, and we say series is the summation of the terms of a sequence, isn't it? So, if we want to find the summation of terms in an AP, how do we go about that? That is what we shall consider now. So recall that A plus D, A plus 2D, A plus 3D, A plus 4D, and the rest are what? Consecutive terms of an arithmetic progression. Then their sum, which we know is just to add, isn't it? Is if we denote the sum as Sn, okay, then it means we add A plus D plus A plus 2D plus A plus 3D until we get to the last one, and the third to the last value will be L minus 2D, then L minus D, and then L, where L is the last term, remember? Good. So writing the terms in reverse order, that is just reversing the terms we have here. You know, if you just reverse it, we have not changed anything. Just like saying, if I say Sn is 2 plus 3 plus 4, I can reverse it and it will still be Sn, and I will have 4 plus 3 plus 2. Okay? So just reversing what we have here. Then that means L will come first. That's why we have L plus L minus D plus L minus 2D plus some other terms until we get to A plus 2D, A plus D, and then plus A. That's the first one here. And when we add these two, that's if you add this equation and this equation, we have Sn plus Sn will give us 2 of the Sn, isn't it? Good. Then, adding A plus L. Sorry, A plus L, this and this, we have A plus L. Okay? Then A plus D plus L minus D. Now, what we are going to have is A plus D plus L minus D. You discover that D minus D will be 0, we'll be left with A plus L. That's how we got this second one. Then check the other one. We have A plus 2D. We have A plus 2D plus L minus 2D. L minus 2D. Minus 2D minus 2D will be 0. We left with A plus L. And if you continue, everything will go like that until we finish all the terms you can get in that AP. So you discover that when you do that, it's going to be the first term plus the last term, first term plus the last term, and we have so many of them. So there are about n of the summation that we are going to have. That is the summation of the first and the last term. Right. Since there are n of the A plus L, that is the first plus the last term, then we can now say 2Sn is equals to n into n plus l. Okay? Then if we want to get Sn now, we divide both sides by 2. Then we have Sn is equals to n all over 2 into n plus l. And this formula is very, very important. So this is the formula you can use to find the sum of terms in an AP. If you know n, the number of terms, the first term and also the last term. But recall that our L is the same thing as a plus n minus 1d. That is last term is the same thing as the n term, isn't it? So that means Sn is equivalent to n all over 2 into a, right? Plus we're now substituting here for L. So instead of L now, I'll have a plus n minus 1d. So here now we have a plus a, isn't it? So that it becomes n all over 2 into a plus a, we have 2a, then plus n minus 1d. And this is another very, very important formula. So this formula now, if you know the number of terms n, you know the first term and the common difference, you can easily find the sum of the terms in that arithmetic progression. But here now, if you know the number of terms, the first term and the last term, you can also use it to find the sum of terms in an arithmetic progression. So you take note of these two important formulas for sum of terms in an AP. So we shall take some examples and see how we can apply this formula to solve problems. Okay, the first question here is calculate the sum of the first 30 terms of the AP. And the AP is given in form of series already, but the AP now is very clear. The AP is 1 minus 4 minus 9 minus 14. Okay, so now here the first term A is given as 1. The common difference is the same thing as minus 4 minus 1, which is minus 5. Or you can use minus 9 minus minus 4, still get minus 5. So if you look at this very one, these 3 dots means there are other terms that continue, isn't it? So we don't know the last time in this case. But we have our n, and the n in this case is going to be what? 30. Since they say we should find the sum of the first 30 terms. So we have A, we have D, we have N. That means we are going to use the formula for Sn equals to n all over 2 into 2a plus n minus 1d. N is 30, A is 1, D is minus 5. So we now say S30 is equals to n, that is 30 all over 2 into 2a, that is 2 times 1. We are now making our substitution, isn't it? Plus 30 minus 1 times d minus 5. Alright? So this will give us 30 divided by 2 is 15 into 2 times 1 is 2. 30 minus 1 is 29. So we have 29 times minus 5. Okay? And this will give us 15 into 2. Now let's check it out. 29 times minus 5, that's 29 times 5. 5 times 9 is 45. We have 4. 5 carry 4. 5 times 2 is 10. 10 plus 4, 14. So it's going to be 2 plus 29 times minus 5, which is 2 minus 1, 45. And this will be 15 into 2 minus 145 will give us minus 143. So you times this one by 15, that is 143 times 15. Okay, 5 times 3 is 15, 5 carry 1, 5 times 4 is 20 plus 1, 21, 1 carry 2, 5 times 1 is 5, plus the 2 we carry, we have 7. Then 1 times 3 is 3, 1 times 4, 4, 1 times 1, 1. Then you add this, we have 5 here, we have 4 here, we have 11, 1 carry 1, then we have 2. So the answer will be minus 2,145. That is the sum of the first 30 terms of this very AP. Okay? Now, let's take another question here. The question says, find the sum of the AP 135 up to 101. So if you look at this AP, the first term is given. And what is the first term? 1. So our A is also 1 here. We can get the common difference, of course. Our D will be 3 minus 1 or 5 minus 3. And we use 5 minus 3, which is 2. But this 101 now is equivalent to a last term, since they put some dots and then 101 and then full stop, isn't it? That is our last term. So that means we can use the formula for Sn. That is Sn equals to n all over 2 into n plus l. But the challenge is that we don't know n. They just say find the sum of the AP. And please don't make this mistake and say there are 1, 2, 3, 4 terms. No. This does mean there are many terms in between, and we don't know how many of them are there. So we need to know how many terms are here. But now, if you recall now, we say L, that is our last term, is A plus n minus 1D. So since we know L, which is 101, and we know A, we know D, we can find our n, so that we can go back and use this formula now to find the sum. So we now say 101, that is L, is equals to A, which is 1, plus n minus 1, D is 2. So we have 101 is equals to 1 plus 2n minus 2. So if you collect right terms here, this is 101, bring this one will be minus 1, which is 100. Then if you bring that one, we have 101 minus 1, bring this 2, we have plus 2 equals to 2n. So 101 minus this is 100 plus this is 102 equals to 2n. So we will divide 102, we divide one side by 2. That is 2n all over 2. This will go. Our n will be 51. So that means there are 51 terms in this very AP. And therefore, since there are 51 terms, then they are actually asking us to find the sum of the first 51 terms. So we now say S51 is equals to, now we are substituting into our formula here. That is the formula for sum of terms when you know the first and the last terms. Okay, so we now have S51 is equals to N51 all over 2 into A is 1 plus L 1 or 1. That is 101. Alright, and we now have 51 all over 2 times 101 plus 101 will give us 102, and 2 here 1, 2 here is also 51, so we are going to have 51 times 51, and let's check it out. 51 times 51, 1 times 1 is 1, 1 times 5 is 5, 5 times 1 is 5, 5 times 5 is 25. Add this, we have 1, this is 10, 0 carry 1, we have 6, and then we have 2. So our final answer is 2601. So that is the sum of the first 51 terms of the AP we have there. Right? So we'll pick some examples again, and a little bit applied in nature, and then we see how to go about solving such. Here is the houses on one side of a particular street are assigned odd numbers starting from 11. The sum of the numbers is 551. How many houses are there? Now, let's check this question. Now, that means, let's check, it's an AP, and the AP is made up of the first element, number here is 11, because it says starting from 11, and they are what? Odd numbers. So, the odd numbers are what? 11, 13, 15, 17, and the rest. Okay, so by implication, our A is 11, our D will be 13 minus 11, which is 2. Then they say if the number of the house, so if the sum of the numbers is 551, how many houses are there? That is, we have to find n, but our Sn is 551. We don't know n. That's the question. How many houses are there? So we now say, okay, Sn is n all over 2 into 2a plus n minus 1d. Okay? Now we don't know the last term. If not, we would have used the other formula. So since we don't know the last term, we will use this formula. So our n is what we are looking for. So we have n all over 2 into 2a, and our a is 11, plus n minus 1 times d. Our d is 2, and it's equals to 551. That's our Sn is 551. So this is what we will now solve to see how we can get our n. So if you simplify this one now, we have n all over 2. 2 times 11 is 22. Open this bracket. 2 times n, we'll get 2n. 2 times 1, we have minus 2. And it's equals to 551. Okay. Then check it out. We can collect like times inside the bracket here. So that we have n all over 2 into 22 minus 2 will give us 20. And then here is 2n plus 20 is equals to 551. And of course we can cross multiply this, and that will give us n into 2n plus 20 is equals to 2 times 551. And then open up this bracket to get 2n squared plus 20n is equals to 2 times 551. Now if you check, 2 can go into each of these numbers or each of these terms. So if you divide this by 2, divide this by 2, divide this by 2, this 2 cancel this 2. 2 here will be 1, 2 here will be 10, 2 will go with 2. And then that will give us n squared plus 10n equals to 551. And this is a quadratic equation. Okay? And then we will now rearrange, so we have n squared plus 10n minus 551 equals to 0. And if you can recall how we solve quadratic equations, by factorization, we multiply this by this, and it will give us minus 551n squared. So the two numbers you multiply to get 551, and add to get 10. If you check 19 and 29. Minus 19 plus 29 will give us positive 10. And then minus 19 times 29 equals minus 551. So our factors are minus 19 and 29. So we'll replace 10n here with the factors. That will be n squared minus 19n plus 29n. Then we have minus 551 equals to 0. So when you factorize this one by grouping, that is, group this, also group this. Here, n is common, so we have n into n minus 19 plus here, the common term is 29. Here we'll be left with n minus 19 as well, and that will be equal to 0. Okay, so since these two brackets are the same, we pick one, so we have n minus 19 into n plus 29, that is the numbers outside, is equal to 0. So by implication, n minus 19 is equal to 0, or n plus 20. And therefore, n is equal to 19 or minus 29. As we solve this, we get n to 19. Solve this, we get n to minus 29. But you know, number of houses cannot be negative. So that's it. Therefore, there are 19 houses on the street. And that's all. So we keep the positive value. Now we have another question before us. The question reads, the sum of the first 9 terms of an AP is 72, and the sum of the next 4 terms is 71. Find the AP. So we have to find the AP. Now, here, sum of the first 9 terms means from the first term, second term, up to the 9th term, the sum is what? 72. And remember our formula is Sn equals to n all over 2 into 2a plus n minus 1d. Okay, so we now say S9, that's all the first 9 terms, is equals to 9 all over 2 into 2a, we don't know the first term, plus 9 minus 1d, we don't also know the common difference. So we now have 9 all over 2 into 2a plus 9 minus 1 is 8d, and is equals to what now? 72. Since the first 9 terms, if you add, you get 72. So simplify this, and then we have equation 1. So this will be 9 into 2a plus 8d equals to 2 times 72. That is cross multiply or multiply by the LCM, which is 2. So if you open this bracket, we have 18a plus 9 times 8 is 72d equals to 2 times 72. We have 2 times 2 is 4, 2 times 7 is 14. So we call this one equation 1. Then let's go back to the next line of the question, and the sum of the next 4 terms. The next 4 terms is 71. That is, if you add from the first to the 9th term, you get 72. Then if you add 4 times after the 9 terms, you get 71. That is to say that the first to the 9th term is equals to 72, right? Then the 9th, after the 9th term, we are going to get the 10th term to, that is the 10th term, the 11th term, the 12th term, and the 13th term. That is to the 13th term. If you add just within this range, you will get 71. By implication, from the first to the 13th term, will be 72 plus 71, and that will give us 1 plus this is 3, and then we have 143. So from the first to the 13th term will be 143. So we are going to use S13 as sum of the first 13 terms, which is going to be 13 all over 2 into 2a plus 13 minus 1d, and that is equals to 143. So you should take note. This one is just an illustration so that we understand what we're doing. Okay. So that means that 13 all over 2 into 2a plus 13 minus 1 is 12d equals 143. So when you cross this or multiply by the LCM, we have 13 into 2a plus 12d equals to 2 times 143, and then open up this bracket, we have 26a plus 12 times 13, this is 6, this is 3, we have 2 and then 1, and that will give us 156. 156d equals to 143 times 2. This is 6, this is 8, and this is 2. We have 286. Okay? And then this becomes equation 2. So we first of all have to solve for our A and our D simultaneously so that we can get the AP. So the first equation is 18a plus 72d equals to 144. And this can be reduced if we divide through by 2 so that we have a small number. This can be reduced to, divide this by 2, we have 9a, divide this by 2, 72 divided by 2, 7 divided by 2 is 3 divided by 1, so we have 36d equals to 72. Okay, and I believe this can still be reduced. Okay, let's keep it like that. Then the second equation is 26a plus 156d equals to 286. This can also be reduced. Divide by 2 here, we have 13a. Divide this by 2, 15 divided by 2 is 7 remainder 1. 16 divided by 2 is 8d equals to 1 divided by 2 is 1. 4, 3. So solve these two equations simultaneously. Okay. Now let's solve this using elimination method. The equations are 9a plus 36 equals to 72, and then 13a plus 78 equals to 140. Let's multiply using elimination method. Eliminate a now. Multiply this one by 13 and then multiply this one by 9. Okay? So 13 times 9. 9 times 3 is 27. 7 carry 2. 9 times 1 is 9 plus 2, 11. So we have 117a plus 36 times 13. 36 times 13. 3 times 8 is 6 is 18. 8 carry 1. 3 times 3 is 9 plus 1, 10. 1 times this one is 6. And then we have 3. If you add this, you have 8, 6, 4. So we have 4, 6, 8, D equals to 7. 2 times 13. This is 6. This is 21. 2, 7. So we have 6 here. 3 and then 9. So we have 9, 36. Then coming here, 13 times 9 is 117a plus 78. 78 times 9. 9 times 8 is 72. 2 carries 7. 9 times 7 is 63. 63 plus 7 is 70. So we have 702D equals to 143 times 9. 9 times 3 is 27, 7 carry 2. 9 times 4 is 36 plus 2, 38. 8 carry 3. 9 times 1 is 9 plus 3, 12. So we have 1, 2, 8, 7. So by elimination method now, we can subtract 117a minus 117a is 0. 468d minus this, the same thing as saying 702 minus 468. So 2 minus 8 cannot, you make it borrow, bring it here, 9, take it here, 12. 12 minus 8 is 4. Remaining 9 here, 9 minus 6 is 3. And then we are left with 8. Sorry, we are left with 6. 6 minus 4, 2. So we have 2, 3, 4d equals 2. And it's going to be minus, since it's this minus this. And then here, I can now say 1287 minus 936. This is 1. This is 5. 12 minus 9. 12 minus 9, 12 minus 9, that's 2. 7 and 9, we have 3. So we have 351. And it's going to be minus as well. Since this one is smaller, 351. So if you divide both sides by minus 2, 3, 4, this will go with this. Minus 2, 3, 4. This minus will go with this minus. D will be 351 divided by 2, 3, 4. Will get 1.5. That's our D. Now, this equation can still be reduced in case you do not like big values. We can divide this 9 by 3 to give us 3a. Divide this 36 by 3, we have 12d. Divide this 72 by 3, we have 72 divided 3, we have 24. And then here, 13 can go here. 13 divided by 13 is 1, plus 78 divided by 13, we have 6d, and then 143 divided by 13, we have 11. And then from here, if you want to still use the elimination method, we multiply this one by 1, since the equation of a is 1 here, we multiply this one by 3. Then you now have 3a plus 12d equals to 24. This one will give us 3a plus 18d equals to 33. So that if you subtract, this one will be 0. This will give us minus 6d. This will be minus 9. And if you divide by minus 6, divide by minus 6, our d will still be 1.5. So I'm going to use one of the reduced equation here. I will use this equation to find a. So a plus 6d equals to 11. Now I have a plus 6 into D is 1.5. So after is 1.5 is equals to 11. So I have A plus 6 times 1.5 is 9, and it equals to 11. So that A will be 11 minus 9, or A will be 2. That's our first term, is 2. But the question says we find the AP, isn't it? So the AP will be, the first term is A, which is 2. The second term will be 2 plus the common difference, and our common difference D is 1.5, isn't it? So it's going to be 2 plus 1.5, which will be 3.5, plus another 1.5, which will be 5, plus 1.5, we'll have 6.5, plus 1.5, and 7, we'll have 8, and it continues like that. So that is our arithmetic progression. Thank you.